Okay.
Alrighty. First thing I want to do is so this is what I'm working on at work. It's a space robotic system that's going to 3D print um, the world's first manufactured solar panel in outer space. It's going to be going up in 2022. I'm designing the computer. You see that it's 3D printing the beam, and at the same time, it's unrolling solar film. So it's going to be a meter wide, and it's going to be 10 meters long. We originally were going to do 15, but I think they cut it down to 10. So that's that's like feet. It's like 3 feet by 30 feet. And so I'm designing the CPU board for this, and it uses RTG4 rad hard FPGAs. The micro semi FPGAs have the flash configuration so that you don't have an external config. I did research into Xilinx versus, which is the RAM based configuration versus the micro semi flash, and the flash is much more robust in space. It's much harder to flip a bit in a flash bit than it is RAM. So Xilinx, it has a lot of hardware in space. So don't let me leave an idea that you can't use Xilinx in space. There's a lot of Xilinx in space, but what they have to do, because their configuration RAM is more susceptible, is they do what's called scrubbing. And so they have a process built into the FPGA that's basically kind of doing a CRC on configuration memory. And if it finds an error, it reboots the the FPGA, because the Xilinx has an external flash chip that does the configuration, and it will just reload it and then keep going. I personally chose the micro semi, and some engineers were fighting for the Xilinx at the time, but I like stuff that is super robust. So this is it's a robot I designed. It's called Intruder, and it was the very first man-packable robot for the U.S. military back in. Let me just turn down the volume here. This was the first, actually the second man-packable robot, which I designed and supplied to the U.S. military before iRobot came out with their PackBot. The one with the flippers on it, the TrackBot with the flippers on the front. That's called PackBot. So back in '97, I hooked up with a guy, Colonel John Blitch, with U.S. Special Forces, and he had an $80,000 grant from the the Army AI lab, to see if a man-packable robot, one that would fit in a soldier's backpack, could be useful. Because back in those days, the military saw a Humvee-sized robot is what they're thinking. So it's mainly used for reconnaissance and that sort of thing. So I built the first one, and he did a lot of demonstrations with it. And then this is my second generation one. This would go out a mile. It's got Forth is the controller. I'm using the new micros Forth, if you guys remember that, Max Forth. So I had a custom board that I designed, and I designed my own robot control language. And this is running this robot. So this would use a 19.2 high power RS-232 radios. They're very expensive radios at the time, and it could go out a mile. And the military is more interested in remote control than autonomous at that point in time, because they just wanted to get something in the field where they could get a remote distance. There's Southwest Technical Research, which is a government lab, called me up one day because I was doing work with them under Blitz's program, and said, we want to give you a PO for one of your Intruder robots, which is what you're looking at now. And I said, great. They go, how much is it? 25 grand. Cool. Write me a PO. And then I'm ready to deliver it. And I said, and they said, Don, we want you to come out for 4 days. We'll pay you, we'll pay you per diem and all that stuff, your plane flight and everything. I was a little younger back then. And so they flew me out there, and I spent 4 days teaching people how to use it. And this one guy took me to dinner my last day, and he says, Don, I'm actually with the CIA, and we're going to use your robot on a real mission. And he said, I can't tell you what it is, but we're going to mount an arm on it, and we're going to go through a chain link fence, and we're going to shoot a vial into this water and get a sample. So that was the very first man-packable robot the U.S. military ever bought. Actually, that was CIA, I guess. But the U.S. Special Forces bought my very first one. So actually, I sold one to the military too. When the Kosovo War was going on, they were going to buy 10 of these things for the Kosovo War. And it was, so the PO was in process, but they finished the war, and so they didn't go through with the PO. So let's see. So back in those days, now this is back in the Wayback Machine, because I even lost the, my Angelus Research, somebody else got it and they want to sell it back for $1 zillion. But all my robots used MaxForth, and I created what I call it an artificial intelligence operating system. So basically, you got the PC board here. What happened was I was trying to build a robot that had instincts and behaviors. In other words, I thought it was silly to have a robot that you have to program. You have to say, if you're in this situation, do this thing, and you have this humongous amount of code. I wanted to try to break it down into an operating system / language that would allow you to program it like you're teaching a child. So what I did was I created what was called the instinct level. The instinct level was an ISR. So in MaxForth, I had an ISR, and when it called the ISR, what it did was it did all the motor control. It acquired all the sensors. It did some pre-processing on the sensors and updated some registers and stuff like that. It did that in the background, so it leaves the foreground tasks for my program. And so if you think about a robot with two whiskers, right, a left and a right. Well, if you have an instinct, it just reacts. It's motor sensor fusion. So let's just say that there's 2 Coke bottles, and this sensor touches it. It automatically backs up, but as soon as the sensor isn't activated, it goes forward again. So it'll just sit there and it'll oscillate back and forth, just using the instinct level. So I decided I need something to arbitrate that, and I created a task list, and I called it the behavior level. So at the end of the ISR, about every 16th ISR, I call the behavior level, because it doesn't need to operate that fast. So 20 times a second is more than enough. And so you create a behavior that says, if both whiskers are hit, I'm basically going to keep control of the processor. I'm going to back up. I'm going to turn. I'm going to go around the object, and then the behavior terminates. So now the outer level, I call the goal level, and that's more like your cerebral cortex. And so the goal level all you have is let's just say a program that's using sonar, say, to look at a door. And one of the behaviors in the robot is you hold a compass heading. So let's say the compass heading is 270 degrees. So the sonar is looking for the door. This behavior interrupts where the robot's going. It navigates around it just using the behavior, no additional code. And when the behavior terminates, the sensor says, "Oh, now the door is at 250 degrees," and so I have a behavior that's a compass, and it'll get it back on the compass course. So the outer goal level would just set the heading that it wants, and these three levels will interact with each other and get you intelligently across, a floor. And if somebody walks in front of it, it instantly reacts. It goes around them, and it was really good for collision avoidance. So I was at a show, a technical show one time, and I was explaining my 3-level architecture to this lady, and she was a biologist. She goes, "Well, that's the triune brain." And I said, "What's that?" Well, it turns out I emulated nature. I was solving an engineering problem, and I emulated the way that we work, nature. So the brain stem in your nervous system is motor sensor fusion. You touch something hot, your nervous system automatically pulls your finger away. You don't think about it, and then you start processing it. Right? That's your conscious level. That's your cerebral cortex. The limbic system is like, breathing is automatic, right? But you can override it. So that's your limbic system. And those three working together makes us very intelligent. So my 3-level architecture is what I designed for intelligent robots. And I designed a lot of different robots. Let's see. Just kind of show you some of them. So this robot was actually a line following robot that I designed for a Georgia technical museum, called it Stock Boy. And basically what it did was you paint a white line on the floor, and you can move the line around, and whatever the new path is, it will follow that. These light sensors can detect people in front of it, automatically stop. There was there's a belt on the top, and there was two lights. There's a light beam that goes across here. So what it would do is go over to a conveyor belt, and when the box came down, it would just go with the conveyor belt and stop, and it waited until the light beam was broken. When the light beam was broken because a box came off the conveyor, it turns on the belt, it pulls the box on there, and then it goes to the other end and it drops the box. So that's one of the robots that I designed. Everything is Forth. I sold 2,000 of these guys. This is called Whiskers Robot. Now I sold these into tech ed. So they went into junior high and high school, tech ed. Remember, tech ed replaced shop. So it used my 3-level architecture, and it was a fun little robot. It even had a frustration behavior. So if you went like this in front of his eyes, if you went, this behavior would count the number of times that a collision sensor got activated, and if it went up a certain amount of increments, it would start a frustration behavior where the robot would stop, the rock back and forth, making a weird sound, and then do a random compass heading, and then take off again. And no matter what the program is telling it to do, that would happen. If it comes around and goes to the task list, then there was no sensors that got hit, it decremented that frustration, level. So kids like this. They were programming in Forth. Forward 10 feet stop is real code. In 10 hours, they would learn how to program, and they're using Forth. And there was, 20, 30,000 students a year in the 90s were learning programming on the Whiskers Robot with Forth. So I'm probably gone over my time a bit. Just show you a couple more robots, and then, so this is advanced. This one is advanced Whiskers. So what I did was I used two of my boards, and I had a network connector on there. And so one board would run the base, do collision avoidance, and the second board, I developed a sonar using piezoelectric, which means that I could see right up to the face, that I could see out 20 feet, and the head would move back and forth. And you can see light sensors under here, and they could see things. And so the two boards working together made a very intelligent robot. And let's see, that's basically it. So is there any questions? Where do I stop sharing?
That's amazing, the little Whisker robot used for school. That's really very nice.
Yeah, I sold 2,000 of them.
That's fantastic. I don't suppose you saw the Stop and Shop robot that detects spillages.
Detects what?
The Stop and Shop robot that detects spillages and tells you, clean up an aisle 5 or something.
Oh.
I'll share that for you if you like. Interest.
Don, I think Young is asking in the chat box if you're making any of your code open source.
Yes, as a matter of fact, Dr. Ting has it, and we have another guy, Brad. Brad Nelson is an awesome Forth programmer. We need to get him in the group. He's got it working on this board. This is my new Whiskers board, essentially, which Dr. Ting has been waiting over a year for. But I'm going to make it open hardware, open source. Go for it. You want to start a company with it around my board? Go for it. I want to kind of lead. It's kind of my legacy. You know, you get older and you want to leave something behind. So this guy is using a ESP32 processor, which has 440K of 32-bit memory, 32-bit processor. Brad's got the Wi-Fi working, so you could use your browser on your computer and control this board remotely using Wi-Fi. It's got Bluetooth on it. So it's got the LEDs for, which is his eyes. I love visible light LEDs for sensors. So they can see out up to 12 inches away. And he's got a speaker on board. He's got a microphone he can hear. He's got, there's 2 motor controls, channels for the, his base motors. I also put in 2 motor controls for, like, the hobby servos, right? So that just takes one line.
And in our website with all these details you could post in the group.
Right. So you got 2 also 2 hobby servo channels on the board too. So you could you could mount the sonar in a pan and tilt head. These boards cost me about $50 when I get them done, and that's my cost. And I've been selling them at cost. So when it's done, I'll let everybody know. And if you're interested in Forth and intelligent machines, you'll get all the source code would be available. We don't have it all ported yet, so it's not really ready. I mean, I'll give you a copy now if you want it, but it's for new micros Forth. So anyway, that's what's going on there. So I'm not busy at all. I was sharing the screen. So here's the board. that I was talking about.
Yes. No.
So that's an ESP32 processor, and you got the light. That's his eyes, the LEDs.
All
So
right,
that's my
very cool. So I think the next talk is Bill Ragsdale.
I think Bill has left.
In that case, I guess we're all set then. If there's anything else anyone wanted to discuss, but great as always.
If it's okay, I'll just share quickly the Stop and Shop robot, if anybody has seen that before.